Hello everyone and welcome to another problem solving session with Special Maths Academy. And in today's video, we are going to cover a problem from the Senior First Round Maths Olympiad 2020. It's problem 5 we are going to be discussing today, and the question goes like this. Let f be a function that maps real numbers to real numbers and consider the following conditions. So there are 5 conditions here. They say the question asks us to find which pair of conditions doesn't yield a unique solution. So there are also 5 options. As you can see, based on the way the question is written, we actually have to check out each option individually to check if it yields or if it doesn't yield. So normally we start in chronological order. So we start with option A. So it says condition I and condition V. What's condition I? f of x plus 1 plus f of x. What's condition V? f of x minus f of x plus x minus 2. So now we have to try to combine these two. Well, the question is asking us to check if there exists a function that satisfies these two properties. Like these conditions here means property. We can say this condition 1, condition 2. So just have to play around with the f's and try and get some things in one equation in the other equation to simplify it. So the best thing I could think of was to replace x with f of x with f of x in equation 1. So when we do that, what do we get? We get f of x plus 1 equals f of x. So we have f of x. We know it based from equation 2, so we can replace it back. We can replace it into this and we get that x minus 1 equals to x minus 2. So we can now replace x with x plus 1 and get f of x equals to x minus 1. Now, so we have gotten this equation now. It doesn't necessarily mean that this will be a solution to this function. It just means that if there is a solution to this function, then this function implies this, but this does not generally imply this function. So that's why it's necessary to actually substitute this f of x equals x minus 1 into the original functions. The two properties we got, and check if it satisfies those two properties. If it satisfies those two properties, then we can now conclude that it is a unique solution. We just have to do that, and it's not so difficult to do that. So in this first one now, when we are checking, we just replace f of x with x minus 1. What do you get? Okay, f of x minus 1 plus 1, that's x equals to f of x. So it's an identity, so that's correct. And the second one, get f of x minus 2 is equals to f of x minus 1 plus x minus 2. So and this is also definitely true. X minus 1 minus 1, yeah, it's also true. So we have gotten that the first property yields a unique solution. Sorry, the first option yields a unique solution. So that is not the answer. We now go to option B. So what's option B? I says f of minus f of x equals to minus x. That's for the and the I property says that f of x plus 1 equals to f of x. So now, as similar as we did above, we can say let this be our equation 1, let this be our equation 2. But just have to find a way to manipulate this and get something out. So what I thought of was to multiply both sides of equation 2 by minus 1. So we'll get negative f of x plus 1 is equals to negative f of x. So now the reason why I did this was because I want to now take f of both sides, so I can use this fact to simplify this right hand side. So now when we take f of both sides of this new equation 2, get f of minus f of x plus 1. There are a lot of f's here and a lot of brackets here, so we just have to be careful to make sure we're not missing things out. So now this f of minus f of x is equals to minus x based on the first property or first condition. Yeah. And similarly, this f of minus f of this, what we can do here is if you replace x with what is inside this bracket, f of x plus 1, it will imply that what we have here is equals to what? Minus f of x plus 1, right? Okay. So we have this. So what does it imply? It implies that f of x plus 1 is equals to x plus f of x is equals to x minus 1 again. So now, as I said earlier on, we have to now like actually check this explicitly. We have to plug it back into these two properties and check if it actually holds. So only then we can now conclude that it has a unique solution. So check f of x equals x minus 1 into these two properties and check whether they are valid or not. So so now let's check f of x equals x minus 1. So what do we have here when we're checking? Let me use a different marker to show that we're checking. F of x minus 1 will be minus x plus 1 is equals minus x. So when we like subtract 1 from this here, we get minus x. So this is true, as you can see. And this one we have f of x minus 1 plus 1 is equals f of x. Yeah, of course, 1 counts minus 1 and it's an identity. So it's also true. So it means that the first and second conditions, like, they are both correct. So they don't use a square. They don't use a. They are both like they both use a unique solution. So they are both not the answer. So the ones I'm ticking in green with a green tick are the ones that use the unique solution. So now option C is where things start getting a little bit tricky. So option C now, what are the two properties or two conditions there? IV and III. So IV is f of x is equals to f of x plus 1. And what is III? III is f of minus f of x is equals to minus x. So now, what we are going to do is we are going to replace. Okay, so what we are going to do now is we are going to replace x with f of x. Yeah. So when we replace x with f of x in, let's call this equation 1, call this equation 2. So when we replace x with f of x in the second equation, what do we get? We get f of minus f of x is equals to minus f of x. So f of x has already been defined to be this. So we'll just substitute it now. So we'll get what? F of minus f of x plus 1 is equals to minus f of x. So from here now, what can we do? Okay, so you see that yeah, this question, like, generally the way things are going around, substitution may be using only substitution to solve this may be really difficult. So we'll actually now try to explore some properties of f. Okay, so now if you look at this second equation, we can get that f is injective because, like, an injective function is a function that satisfies this equivalence if f of a is equals f of b, if and only if a is equals to b. So one side of the equivalence is obvious. That's the side when a equals to b implies f of a equals f of b. But injectivity, like, is the part that is like less non-trivial, is the other side. When f of a equals f of b, it implies f of a equals b. And it's not so difficult to show that this function is injective. I'll just leave it to the reader to do that. So now, from the fact that this function is injective, we can also get that this function is also surjective. Why? Because this right hand side now, let's consider one side of the equation. On this left hand side, we have f of some terms that are members of real numbers equals to a function that is surjective, like the line, the graph, minus x goes like this, covers the whole real numbers. Like for any real number, for any, like you can plug in for, if you want to like make f of a member of the domain to be equals any real number, I can always do that because just set x to be negative that real number. So that implies that the function is surjective. And because the function is surjective, from this our first equation, we have that f of x is equals to f of x plus 1. Because f is surjective, we can, in a way, say that for all y, member of real numbers, there exists a t such that f of t is equals to y. So y is general and t is also like general, but it depends on y. Or it can also like so like we can say this like this statement is true because the function is surjective. So we now set x to be equals to t. So when I set x to be equals to t, what do we get? We get that f of y is equals to y plus 1. So this solution satisfies we get the solution at this point. So remember, as we did in the first two options, we had to test them back into the two conditions to verify if they actually hold or not. So I have to like test this function f of y equals y plus 1 into these two equations to actually check if it gets equivalent functions. So now in this second equation, let's test it out. Okay, I'll use red pen when I'm testing. So this f of minus f of x will be what? Minus x minus 1. So when I add minus x minus 1 plus 1, does it give this right hand side? Yes. So let's check this first one now. F of x plus 1, does it give us x plus 2? So yeah, it's also true. Add 1 to x plus 1, get x plus 2. Now, so that also means that the third option here is use a unique solution x plus 1, f of x equals x plus 1, or f of y equals y plus 1. The variable doesn't really matter. So now the fourth option, let's check it out. When we combine condition ii and condition iv, so condition ii gives us f of x equals x plus 2, and condition iv gives us f of x equals f of x plus 1. So if you notice, both equations have f of x on the left hand side of both equations. So we can just equate both right hand sides together. So get x plus 2 is equals to f of x plus 1. So what does it give us? It gives us f of x equals x plus 1. So remember, I have to now check it back into these two equations, and it's very easy to see that to hold. So just for this, f of x plus 1. So when I add 1 to this, get x plus 2. So this first one is true. So that one is f of x plus 1 plus x plus 2 is also true. Yeah, it's also true. So this condition D also is a unique solution. So it means that the answer is option E. So it means the answer is option E. We can like still try to show that actually option E gives a contradiction, but it's not really necessary and it's a bit long, so I'll just skip it out of this video. But we have shown that the first four options give a unique solution. So the only option we have not really shown if it gives a unique solution or not is option E. But I just leave it to the reader to actually show that it doesn't give a unique solution. You read out to the person watching this video to actually show that it doesn't yield a unique solution. So that's all we have for today. And the answer to this question is option E, because it's an objective exam. So feel free and explain to me in the comment section how you were able to like show that option E doesn't yield a unique solution. And that this is all we have for today, and I'll see you in the next video.